All I want from you right now is to give me a like. This video isn't short. In fact, it's not short at all. So go ahead, settle into your favorite spot. Maybe pour yourself a little tea or coffee, or just lean back and let your mind drift. Because what you're about to hear is a long and sleepy journey. We'll travel along the edges of the universe to places no one has ever stepped foot, places we can only reach through thought. And our first stop on this quiet voyage, square black holes. I know what you might be thinking. Wait, aren't they supposed to be round? Yes, but maybe not exactly. The idea of a square black hole isn't really about a physical object you could point to in the sky. It's more of a thought experiment, something that lives in the world of geometry and equations, not telescopes and photographs. We're all familiar with the classic concept of a black hole. A massive star collapses in on itself, forming a region so dense, not even light can escape its gravity, a quiet singularity in space. But here's the strange part. The universe isn't shaped like a smooth, perfect sheet. It bends, it curves, it folds at the edges, and as we move through it, we're constantly brushing up against those invisible warps. That's where the idea of a square black hole comes from. Not a shape problem, but a geometry problem. Under certain conditions, some scientists have proposed that the shape or behavior of a black hole, at least mathematically, might not be perfectly spherical. It might, in very specific situations, act more like a square. No, there's not a big spinning cube in the sky, but in the realm of equations, where Einstein's ideas live and breathe, there are solutions that suggest a black hole's structure or event horizon could take on strange, angular features. So when we say square black hole, we don't mean a cube in space. We're talking about how space-time behaves when bent under different rules. It's about what the math allows, and how those numbers might whisper something new about reality. The story of black holes begins in the 18th century, when early thinkers tried to understand gravity using Newton's ideas. But true black holes didn't emerge until 1915, when Albert Einstein introduced his general theory of relativity. All I want from you right now is to give me a like. It said that mass bends the fabric of space and time, and in 1916, a physicist named Carl Schwarzschild found the very first solution to Einstein's equations, the Schwarzschild black hole. But that was only the beginning. Over time, scientists uncovered more exotic forms, spinning black holes called Kerr black holes, electrically charged ones called Reissner-Nordstrom black holes, and even combinations of the two, like the Kerr-Newman solution. Some of these, under very special conditions, started showing odd geometric behavior, symmetries that weren't perfectly round, shapes that bent the rules just enough to make physicists pause. That's where the square iso quietly reappears, in a special kind of universe called anti-de Sitter space, something with curved edges and strange boundaries. Mathematicians realized that black hole solutions might not always be smooth and spherical. They could, in theory, have flat surfaces, even squared-off features, not in a visual sense, but in the way their gravity works, in the structure of space-time near their event horizons. It's not about what they look like. It's about what they are, deep down in the math. Einstein had mixed feelings about black holes. He wasn't entirely comfortable with where his own theory had led. In fact, some accounts suggest he didn't even believe black holes But over time, his equations inspired others, and those people pushed the math. They explored the impossible, and some of them uncovered solutions that, in a strange and subtle way, behaved a bit like squares. Here's the thing. Einstein's equations are really a guide to geometry. They describe how space and time bend and curve under certain conditions, and when those boundary conditions shift, when the rules change just slightly, the solutions might not look spherical at all. They might still be black holes, just not the kind we're used to. In certain virtual models, in theoretical universes beyond our own, structures could emerge, built not from mass, but from flows of energy. And in those rare cases, their event horizons might carry the symmetry of a square, not in appearance, but in the way space-time folds around them. Now, let's gently drift into the more technical part. What makes these square black holes different? The most striking difference lies in the shape of the event horizon. Normally, a black hole's event horizon is spherical, a perfect bubble in space. But in some topological black hole models, the event horizon could be a flat surface. So what does that actually mean? It means gravity might behave directionally. Instead of being the same in all directions, it could vary, an effect called anisotropy. Light might bend differently, matter might flow unevenly. Even Hawking radiation, the soft whisper of energy that leaks from black holes, could behave in unexpected ways. Some models suggest that these square-like black holes might only exist at the very edges of reality, far beyond what we can observe. So that could mean they don't exist in our universe at all. They might belong to other possible universes. Or perhaps they serve as theoretical tools, test models for exploring quantum gravity. Scientists aren't trying to observe square black holes directly, because physically, they probably don't exist in any traditional sense. But in theories like the ADS-CFT correspondence, these types of black holes offer valuable lessons. They teach us about quantum information, about the holographic nature of the universe, and even about the symmetry of time itself. The square black hole is more than a curiosity. It's a quiet, abstract tool, one that could help us simulate the early universe, or design better particle experiments, or build bridges between physics and geometry in ways we haven't yet imagined. And who knows, maybe one day, a telescope will catch something unexpected, and in the shadows, it won't be a perfect circle that greets us, but something with just a few more edges. İşte böyle. Bir yuvarlak delikten köşeli olasılıklara, Einstein'dan hayal gücüne uzanan bir hikayeydi. Ama unutmayın, bu video sadece bir başlangıçtı. Uykulu bir yolculuğun ilk durağı. Birazdan başka konulara geçeceğiz. Evrenin başka garipliklerini, belki zamanda yolculuk, belki dördüncü boyut, belki de ışığın altına gizlenen başka sırlar. Ama şimdi kara delikleri geride bırakıyoruz. Sıradaki durakta görüşmek üzere. DNA, the mysterious codes of life, and the latest discoveries in modern science. Hello, today we will embark on a long, calm, and deep journey into the fascinating world of DNA. This video will last about 15 minutes, so relax and gently step into the mysteries of science. DNA, or deoxyribonucleic acid, is the fundamental building block of life. Inside our cells, it holds all the information that makes us who we are. Every living thing, whether a tiny bacterium or a massive tree, carries its genetic within DNA. When the structure of DNA was discovered in 1953 by James Watson and Francis Crick, it sparked a major revolution in the scientific world. Since then, research on DNA has made great strides in unraveling the secrets of life. But today, we see DNA not only as a molecule carrying genetic information, but also as the meeting point of modern biotechnology, medicine, and even artificial intelligence. Today, we'll explore what DNA has achieved in recent years and the new discoveries scientists are making that aim to change our lives. First, let's touch on the revolutionary advances in genetic editing. You may have heard of CRISPR. CRISPR is a tool that allows us to make very precise and effective changes to the genetic code. Yet, scientists have gone beyond CRISPR, developing even more sophisticated techniques. For example, new methods called prime editing and base editing allow us to edit the genetic code in an even more precise and clean way. With these methods, small but critical changes can be made to a single letter or base pair in the DNA. This makes correcting mutations that cause diseases much safer and more reliable. Prime editing can fix errors by directly changing bases in the DNA without cutting the strand. This means far fewer mistakes and side effects compared to older methods. Although still in the lab research phase, it is expected to revolutionize the treatment of genetic diseases in the future. On the other hand, base editing allows a single D base, one of the letters A, T, C, or G, to be directly swapped for another. This makes it possible to make very specific and small yet meaningful changes to the genetic code. These techniques not only correct diseases, but also open new frontiers in biotechnology and agriculture. For example, developing disease-resistant plants or creating microorganisms that produce biofuels has become much more achievable. This precise control over DNA opens the door to a new era for humanity. Yet ethical and safety concerns remain just as important. The limits of genetic interventions, their social impacts, and long-term consequences are topics of ongoing debate in the scientific community. Now, get ready to learn how DNA is not just a carrier of genetic code, but also opening new horizons through its combination with artificial intelligence. In recent years, the interaction between DNA data and AI technologies has created incredible opportunities in biomedical research. Understanding the human genome and genetic variations has become faster and more accurate thanks to AI algorithms. For instance, solving the genetic origins of diseases and developing personalized treatments have become much more accessible. AI can analyze millions of DNA sequences and quickly reveal which genetic combinations increase the risk for specific diseases. Moreover, drug discovery is speeding up with these methods. Scientists rely on AI to identify target molecules in DNA and pinpoint potential drug candidates, enabling the development of safer and more effective treatments. This means that the medicine of the future will be shaped by a perfect partnership between DNA and artificial intelligence. On the other hand, DNA is revolutionizing not only our biological information, but also data storage. Recent research shows that thanks to DNA's incredible density for storing information, we may soon be able to store digital data at the molecular level. Imagine fitting the that in the future, DNA-based storage devices will replace traditional data centers. Now, let's take a brief look at how DNA helps us unlock the secrets of evolution. DNA is one of the most important tools for understanding how species have evolved and changed over millions of years. Small differences in our genomes reveal adaptations, migrations, and ways we've fought diseases throughout history. Thanks to DNA analysis, scientists can access the genetic information of even extinct creatures and map their evolutionary connections. The genetic exchange between Neanderthals and modern humans is clearly visible even thousands of years later. Furthermore, studies on DNA help us understand how species adapt to environmental changes and the speed at which evolution occurs. New methods in this field are creating a revolution in evolutionary biology. With genetic data, we can examine the complex history of life in more detail than ever choose to use it. Göbekli Tepe, the Sumerians, and Egypt. They stand as silent witnesses of the past, and perhaps they still have much to tell us. They just need ears willing to listen. The mysterious world beneath the ocean. Silent, dark, and extraordinary. Nearly 70% of Earth's surface is covered by water. These vast oceans are among the least explored regions of our planet. Throughout history, humanity has tried to chart the seas, yet the deep ocean remains shrouded in mystery. Tonight, we'll take a long, peaceful journey into that quiet, dark underwater world. So gently close your eyes, take a deep breath, and let yourself drift into the mysterious silence of the deep sea. Far beneath the surface, where sunlight never reaches, lies a realm of crushing pressure, freezing temperatures, and astonishing life. Against all odds, life not only survives here, it thrives. The creatures of the deep mesmerize scientists with their glowing bodies, strange shapes, and incredible adaptations. The Mariana Trench is the deepest known point on Earth. At nearly 11 kilometers down, even in total darkness and extreme pressure, life still exists. Down here, even man-made machines can only explore for brief periods. Microorganisms, enormous soft-bodied creatures, and oddly shaped fish share this silent, alien world at the ocean floor. One of the most remarkable features of deep-sea life is bioluminescence, the ability to produce light in complete darkness. These glowing displays help creatures navigate, attract mates, or lure prey. Some fish, for instance, emit soft glows from special parts of their bodies, using light as a trap for unsuspecting victims. But bioluminescence isn't limited to fish. Jellyfish, crustaceans, and even certain bacteria possess this magical ability. As jellyfish drift through the calm waters, their gentle rings of light shimmer through the dark, creating a mesmerizing and almost otherworldly scene. Life in the deep ocean exists in a delicate, complex balance. Hydrothermal vents, formed by underwater volcanic activity, release hot, mineral-rich fluids into the surrounding water. Around these vents, creatures survive without sunlight, instead relying on chemical energy. This process, called chemosynthesis, supports a self-contained ecosystem entirely independent of the surface world. Among the residents of these extreme zones are giant tube worms, colonies of bacteria, and a variety of deep-sea crustaceans. Despite the intense heat and toxic chemicals, life continues. Scientists believe that studying these areas could offer clues about the possibility of life beyond Earth, perhaps even beneath the icy oceans of distant moons. Thanks to recent technological advances, deep-sea research has made remarkable progress. Autonomous underwater vehicles, or AUVs, now explore the ocean depths for hours without human control. These robotic explorers record footage, measure the chemistry of the water, and quietly observe the secret lives of deep-sea creatures. Current estimates suggest that millions of species in the ocean remain undiscovered. In fact, scientists believe we've identified only around 5% of all marine life. The rest remains hidden, far from the reach of human eyes. This unknown abundance points to a future where ocean biology may become one of the most important fields in science. The hidden balance of the deep. Deep-sea ecosystems also play a critical role in the planet's carbon cycle. Many of the organisms living on the ocean floor Let the silence guide you. Drift slowly, breathe deeply. The journey through the deep is long, and it's meant to be. Sometimes, a light flickers in the darkness. It may not always signify what's going. Bioluminescence, the ability of living creatures to produce their own light, is one of the most enchanting mysteries of the ocean. This glow can be used to escape danger, to attract prey, or to find a mate, especially in the mesopelagic zone, known as the twilight zone. Many creatures possess this fascinating skill. As depth increases and sunlight disappears entirely, life continues to shine. Take the anglerfish, for example. With a glowing lure dangling from its forehead, it waits in stillness. The light sways softly in the water, beckoning its next meal ever closer, until it's too late. This is evolution in the deepest science. These strange traits are the result of adaptations shaped by millions of years spent in total darkness. Every year, scientists discover dozens of new bioluminescent species, yet most of them are only captured in brief glimpses, visible for mere seconds through remote sensors. Human divers can't reach these zones. At these depths, pressure is hundreds of times greater than at the surface. Below 1,000 meters, the pressure becomes so intense that a human body would be crushed in milliseconds. That's why specially designed underwater robots like ROVs, remotely operated vehicles, and AUVs, autonomous underwater vehicles, are used to explore. These machines can sometimes dive as deep as 10,000 meters, and it's down there that the Hadal Zone begins, named after Hades, the mythological god of the underworld. This zone includes the deepest parts of our oceans. In these regions, temperatures hover near freezing, and pressures can reach more than 1,000 times the atmospheric pressure at sea level. Human technology has only touched this realm a handful of times. One of the most famous visits was in 2012, when filmmaker James Cameron descended into the Mariana Trench in a solo submersible. He reached a depth of 10,900 meters, uncovering a dark abyss that left researchers with more questions than answers. For instance, some of the tracks found there, strange, evenly spaced markings, were observed in the soft seabed mud. No known marine creature is responsible. Giant squids. No. Eels or crustaceans. Not likely. These patterns don't match their movements. Some scientists believe these formations may result from geological activity. Others argue they could be made by species we've yet to discover. A few speculative researchers even suggest the idea of non-Earth life forms leaving behind those marks. But the most compelling theory may be this. The deep ocean is a time capsule. Species long thought extinct. Creatures that once roamed the earth during the time of the dinosaurs may have found refuge in these black depths. The discovery of the coelacanth supports this. This fish was believed to have gone extinct 65 million years ago, until it was found alive in 1938 near a coastal area. Somehow, it had survived all this time in the ocean's hidden zones. This opens the door to a haunting question. What else is still hidden beneath the surface? Far from modern eyes, could ancient civilizations lie undisturbed? Could there be unknown species or secrets that redefine human origins? In 2023, an expedition offered a new clue. In a remote part of the South Pacific near Tonga, researchers discovered perfectly symmetrical stone structures deep below the surface. The formations were far too orderly to be a product of chance. Nature doesn't tend to build this way.